In lesson 5, we're gonna analyze a truss, which is one of the basic or one of the examples that we go through in statics through mechanical engineering education. So today I'm gonna teach you how to analyze a simple truss, and the whole idea is the same. You just have to define your elements and your model and any geometry that you're given, and apply the loads and constraints, and then you can analyze your truss if everything is well or properly defined. So the truss I'm gonna analyze in here is gonna be something like this. I'm drawing the nodes. I guess this one shouldn't be here, so let me erase this node, get back to here. So basically I'm going to connect these nodes, and they all have to be in the same exact node. Well, definitely I made a little uh, mistake in here, so let me erase them. This is my node, so I'm going to connect this to here, also connect this one to here, and these nodes to each other. So basically this is the node that this is the truss I'm going to analyze, the model. I'm going to fix this or apply this constraint on the left bottom corner, which means ux, or displacement in x direction, is equal to 0, and u, or displacement in y direction, is equal to 0. And in the right side I'm going to apply this restraint, which means ux or uy is equal to 0, so we have no displacement in y direction, but we have probably some displacement in x direction. So and then the reactions we have in this constraint is going to be some load in y direction and some load in x direction, whereas on the constraint on the right we only have some uh, reaction in the y direction, so we won't have any force in the x direction on this side. In order to avoid symmetry in this truss, to make things a little bit more complicated, I'm going to apply an Fy, or let me change these F's into R because they are reactions and R is going to stand for reaction. And I'm going to say reaction 1 and reaction Y2 in order to avoid confusion. I'm going to call this one Fy, and the node here I'm going to apply an Fx. So we're going to have an external load of Fy applied on this node, and a load applied in x direction on this node. The dimensions I'm going to give is that these nodes are going to be separated by 100 units each. So I have 300 units length in the bottom. These ones at the top are also going to be 100 units. And the one in the middle is going to be 50 units away from this node. And also here is going to be 50, and it goes on. And the material I'm going to be using for my elements is going to be steel with the elasticity of 200 gigapascals and Poisson's ratio of 0.03. This is for my material. And the other thing I want to say in here about this analysis is that the element that we're going to use, or we're going to define for this analysis, is going to be link. This element has real constants, or yeah, I'm going to define a link, and a real constant, which basically what we need to define for this element in real constants is the area, or cross-section area, for which I'm gonna give 1 units to make things easy and easy to calculate. And then we're gonna find the reaction forces in here and here, and we're also going to see the deformation of the truss uh, according to the loads that we're applying in here. Let's say the Fy that I'm going to apply is equal to 200, and the Fx that I'm going to apply is equal to 50. And go through and analyzing this model. Okay, let's switch to ANSYS. Alright, we're in ANSYS, so let's try doing or modeling the truss in here. The first thing is I'm going to preferences and select structures to make sure that everything I'm seeing in the future through this example is going to be structural. Click OK. Come to preprocessor, and like always define an element, add an element, and I'm going to pick element link, and I stick with the first one, 2D, because I'm not concerned about a 3D model still or right now. So let's pick the first one, which is a 2D model or element. And the options, well, link 1 doesn't have any options, so I can cancel this one and close and come to real constants, add for link 1. The cross-sectional area I'm gonna give 1 just for convenience. Click OK and close. Now go to material section, click material models. I'll see structural, linear, elastic, isotropic. Give the elasticity of 2 times 10 to the 11 and the Poisson's ratio of 3 and click OK. So my material is also defined. Now I can come to modeling, and for this case I can basically just define nodes and elements. So I come to nodes, inactive CS, and click or pick nodes. The first node is going to be at x0, y0, apply, and then the next one is going to be at x of 100 and y is 0. Then I go to 200, and then I go to 300 and apply, and then I can come to 50 and the y of 100 and apply, and then pick 150 and it's the y of 100 and again apply, and then the y of 250 and x of 250 and y of 100. Click OK. All my nodes are generated here. Then I can pick elements. Elements, auto-numbered through nodes. Pick each element, click apply, go from here, apply, apply. So basically this is the way you make your elements. Okay, so this is the basic form of the truss that I generated. And because I used nodes and elements to make this model, I don't need to go through meshing. So after modeling, I can jump into loads, come to analysis type, and make sure that I'm doing a static analysis. Click OK. Now jump to define loads, click apply, and I'm still doing some structural. For the first, I'm going to apply the constraints. So on this node, on the left, bottom left node, I'm going to say give me ux and uy of 0, apply, and then on node 4 I'm going to say only uy is 0 and ux is not 0. So the constraints are also defined. Now the other thing I want to apply is the force. Again on the nodes, click on the node, pick node 5, and on here we're going to define an f of minus 200, and the reason I'm picking minus 200 is that my force is going to be applied downwards, which is in the negative direction, negative y direction. So I'm going to click OK, then click on the node again, and this time I'm going to pick node 7, click OK, and fx. And again, since I'm going to the negative x direction, so I have to put minus 50 and click OK. So basically my model is ready now. So what I have to do is to come to solution, pick solve, current ls, OK, and my solution is done. Now I can jump to general post process. The first thing I want to see is the deformation of my truss. I always like to put in deformation plus undeformed, and this is the way my truss is deformed based on the loads that we applied. If you see in here, the node 7 or node 4 has also moved to the right a little bit, but node 1 has not shifted at all in x or y direction. Now counterplot, go to nodal solution, and the first thing I want to see is displacement vector sum. So we have no displacement in here, but the maximum displacement, total displacement actually, is in top left corner. Now let's see the displacement in y direction. Again, nothing in here. And as you see in this graph, all the values are in negative because my truss, according to the loads that we applied to it, is moving in the negative direction according to y coordinate. So basically we can see the deformation of the truss. Let's see deformation in x direction as well. Again, here we don't have any on bottom left corner we don't have any deformation in x direction. And the other thing I want to do here, list results and see reaction solution. I want to see all the forces. Click OK. We only have two nodes that need reactions, the one here and the one in here. And as you see, for node 1, which was this node, we have an fx of 50 and the fy of 183.33 on here. And the reason is that fy was closest to this node than to the other node. And on node 4, which was this node, we only have fy, or reaction in the y direction, of 16.67, which totals the loads to 50 and 200, which were the loads that we applied to the entire truss. Let's see what we can get from nodal solution. Click here and let's see if we can get displacement in x direction for all the nodes. Yes. Node 1, there is no displacement in y direction, and you can get displacement for all of the nodes based on the loads that we applied to the entire truss. We can do the same thing for y direction. Again, there is no displacement in y direction for node 1, and also node 4 doesn't have any displacement in y direction according to the constraint we applied to node 4. But all the other nodes, nodes 2, 3, 5, 6, and 7, have negative displacements. So basically, this is how you define a truss, apply loads and your constraints, and do the analysis and see the deformation of your truss based on the loads that you've applied. And also you can see the nodal solutions and get the displacement for each node, and also you can see the reaction forces on the nodes that you have constraints on. And this concludes lesson 5 on FEA with ANSYS.